This video is to help you analyse your data from your student experiment. I've created some mock data that we can use today, and hopefully it helps you understand how you may decide to interpret your data or analyse your data. So this first table shows the change in mass of algal balls over the entire experiment. It could be that you're looking at number of leaves of duckweed. That's for you and your experiment. This one is day by day and is taken from the average mass each day for each treatment. Now treatment is, for example, pH, it could be colour of light, it could be the concentration of the fertiliser that you used. So you've got a variety of treatments. Some of you have only got 3 different treatments, some of you have got 5 or 6. So that would be this column here. Each of these values that you see here is an average of the mass on this particular day. So you would have had 3 replicates on that you would have used, and from that you've got an average of 16.5 grams. It might be that you've got 25 leaves of duckweed. It depends on what your experiment is. So this becomes a table of the average change in mass, or the average mass of algal balls each day over the experiment. There's no cumulative data here at the moment. This is just looking at changes in mass. So all I've then done is I've highlighted that data, and I've just highlighted this section of data here, and I've inserted a line graph. Now the line graph I like to use is a smooth mark scatter, and when you've done that you can see that over here. And what this is showing you is that on the x-axis here, this is time in days, and on the y-axis, this is the mass of your algal balls. I haven't put all those titles in there, but you can see that we get a pattern. Now, it's a pretty boring pattern here. Yours are going to be quite different, but you should see something along these lines where you can see a pattern for each of your treatments. So Series 1, Series 2, and Series 3 are your 3 different treatments. So that's one way that you can display your data, to just show how things have changed over time. You can see there are differences between the data here. The next thing we need to decide is, well, are those differences significant? This is where we need to look at the means of our data and look at doing both standard error bars and t-tests. So that's my next thing to explain. So let's come over here and see what I've got here. This information here is the change in mass in milligrams of algal balls for each treatment. And it shows that change in mass over the entire experiment for each of the replicates. So different to this one here, where we looked at this is an average of the replicates on this day. This is change in mass in milligrams for treatment 1 over the entire time. Okay, these could be both positive or negative numbers. It depends on your data. For those of you who have seen growth, you're going to see positive numbers here. For those of you who have seen death, you may see negative numbers. You'll see that pretty much I've tried to use the data that we've got here, that we've seen a change in mass here of around about 4 grams in treatment A. So this is showing around about a change in mass of 4 grams. So it's for similar data, but obviously yours is going to look quite different. So to calculate this here, I would be looking at your initial mass and your final mass, and obviously just subtract your initial mass from your final mass. And then you're going to come up with this information here. So if I did that over here, so this is change in mass, and that just equals this number minus my initial number. And you can see that my change in mass over here is 3.85 grams. Kind of similar to what I've got here. But you have to do this for each of your replicates. So this is the change in mass for replicate 1, change in mass for number 2, 3 and 4 within that particular treatment. So we come up with a table here from that that we can actually look at and determine whether the means of this data are actually significantly different. So we're going to now go up to the data column or tab and click on data analysis. If you haven't installed the data analysis pack, make sure you go and do that. But you click on data analysis, and the one you're going to look for is descriptive statistics. So you click on descriptive statistics, you say OK, and we've got to select an input range. My input range is just this data here. Don't worry about any of the words and bits and pieces here. You just want to select the data in your rows. Click on the toggle. Make sure you've selected rows. Click on summary statistics, because that's what we want out of this. And then we're going to select our output range. This is just where we're going to put our data. Click on the toggle again and select a cell on your spreadsheet. I'm selecting it there because I want it just straight underneath. And then I'm going to click OK. And now what I have for treatment 1, treatment 2, and treatment 3, I have information that I can use. The only information that we're going to use from this are the means and the standard errors. So I'm just going to copy that information below here. And I'm going to create a table of means and create a table of standard errors for each of these treatments. So that's nice and simple. So now what I've got is I've got information about my 3 treatments here, and these are the means, and these are our standard errors. So the first thing I need to do with this information here is graph my means. We're going to assume that this is discrete data like colour or distance from a light source. Well, that would be continuous, but let's just assume that we're going to use this as discrete data so that it's a column graph. If it is continuous data, you can use a line graph, but let's just assume it's a column graph. We're going to pick a column graph, our histogram here. Use this one. And we've got our graph now. So this is showing the mean value for the change in, so this is the mean change in mass of each of my treatments over time. And I want to now add my standard error bars. To create standard error bars, I add chart elements, error bars, and more error bar options. I click on the custom option and I specify the value. I put in both the positive and the negative error value as I've done in the previous video. So we click on the toggle, we highlight our standard error, we click on the next toggle, and we highlight the same standard error because that's our top and our bottom of our error bars, and we click OK. Now what we have is we have a graph that shows us each of the mean changes in mass. So this is mean change in mass of algal balls. Our y-axis is showing us the mass in grams. Our x-axis is our treatment. So I've got my 3 means that I can now compare. I can compare them based on the standard error bars. It looks to me like there is a significant difference between each of these because our error bars aren't overlapping. If I want to find out more information about that, I need to go back and do a t-test between 2 of these samples. So if I want to know whether there's a significant difference between treatment 1 and treatment 2, I do a t-test between the 2 of those. I'll show you that. with the information that we have here. So once again, I'm going to go to Data, Data Analysis, and this time I'm going to actually do a t-test to sample assuming equal variances. We say OK. Variable 1 range, I toggle, and I select treatment 1. Remember, we can only compare two means. The variable 2 range is that I'm looking between treatment 1 and treatment 2. So I select treatment 2. I leave my value here as 0.05. I select my output range. I'm going to put it just below here. And I'm going to click OK. Now this is between treatment 1 and treatment 2. And what we can see is that we look at our two-tailed test. We're going to highlight that. And we see that there is a p-value of 0.002. That p-value is less than 0.05. So we are going to reject the null hypothesis. All that means is that we are confident that the difference we are observing between our means, so the difference that we're actually seeing between these two means, is not due to sample error, but is due to the change in treatment. So we can be confident in the values that we're given, and we can be confident that the reason we're seeing those differences is because of what we've done. I really hope this is helpful. I know it's a bit of a rush through on error bars and t-tests. If you want to go back and have a look at that in more detail based on another data set, please go back and have a look at the 2 previous videos. If you've got any other questions, please let me know. Thank you.